Okay, so welcome to today's lesson. Today is, of course, part 2 of our revision series in this math school brought to you by NITEX, as well as the Mathematical Structures Research Group and Absolute X. So in our last lesson, what had we done? We had revised concepts that pertained to number patterns. Sorry, let me just sort that out. Right, so we looked at number patterns. Okay, there seems to be an issue with the writing pad. Let me quickly resolve this. Okay, let me just quickly stop this for a moment and restart the entire Okay, apologies for the delay. I'm trying to reopen the document and then we're good to go. Okay, so this should be displaying on your screens. You could just let me know in the chat box that it does indeed show. And I think it's working a lot better. Okay, so just to proceed, right, what did we do last week? Last week, we had looked at number patterns, as well as we had just started looking at questions pertaining to graphs, right? So this was lesson 1. What are we doing today? Today, we are going to continue investigating specific questions with respect to graphs, and we are also going to tackle the section of trigonometry. All right, so let's get immediately into this. So as usual, I would like for you to have some writing material, pen and paper, so that you can work through the questions with me. The questions that you see in front of you on the screen are questions taken from the Department of Education exams. This in particular is from a November exam, and I believe it was 2021. So let's look at what this in particular says. It says the following. We have that sketched below is the graph f of x, and f of x is given by minus 2x squared plus 4x plus 16. So f is the parabola. Okay, so that is the first thing that we observe, that this is a parabola. Of course, based on what you would have learned about parabolas, there's various properties that one could then talk about when it comes to parabolas. We know that parabolas, the basic form is given by ax squared plus bx plus c. We had also learned that in particular, the turning point. So we know that a in particular tells me that if a is greater than 0, then I know that the graph opens upwards, meaning it has a happy face. If a is negative, I know that the graph opens downwards, meaning that it has a sad face. And then, okay, I'm just double checking our chat box. Right, and then the other bit is that we know something specific about the turning point. Now, it is clear from the picture that has been given to us that C refers to the turning point. In fact, that is precisely what they have told us in the preamble of this question. C is the turning point, and how do we compute turning points? Of course, we can derive the following that I'm about to write, but we know that the x coordinate for the turning point, this is given by x comma y, is equal to minus b over 2a, okay? And this coordinate of the turning point in particular either refers to the maximum value of the parabola, like it is in our case, or if the graph was upward, if it opened upwards, in the sense that it had a happy face, then the x coordinate of the turning point would refer to the minimum value of this function. Okay, now we've got the x coordinate for the turning point. So naturally, if I wanted the y coordinate, then I would then need to calculate f of minus b over 2a, and that would give me the corresponding value. So that's some important things for us to note. Let's now look at the question. The question says, calculate the coordinates of a and b. That is what we're required to do. So I need a and I need b. Where is a? Here's a, and located on the diagram, there is b. Can you tell me, what does a and b on this picture actually represent? I can see that a is a coordinate on the parabola, but a is also a coordinate on the straight line. But then I go ahead and I look at b, and I see that b is a coordinate on the parabola. So what is common between these two points, a and b? Well, these coordinates are points on the graph of the parabola, but what else can you tell me? Yes, and I see we have a response here from Kiur that says it's the x-intercept. And then I have some answers already coming in. So that's wonderful, right? So we essentially want to find the roots of f of x. We want to find the x-intercepts of that graph. So let's go ahead and solve, right? So let's calculate together, and you are going to help me. So I'm now solving 5.1. I know that my function is given by f of x equals to, let's remind ourselves, minus 2x squared. What else is it? Plus 4x plus 16. Right, that is what we have. So what I want to do is I am now going to solve. I'm going to solve f of x equals to 0. So that means I'm solving minus 2x squared plus 4x plus 16 equals to 0. So if I go ahead and I solve that, well, I'm going to divide both sides by negative 2. So that gives me x squared minus 2 x minus 8 equals to 0. And now I'm in a position to factorize. And so if I had to factorize this, this quadratic expression, I then observe that what I get is x minus 4 into x plus 2. Do you all agree with that? You can use the reaction to let me know that you are all good with the factorization up to this point. Great. Okay, so what does this now tell me? Well, this tells me that the x values is then going to be x equals to positive 4, or I've got x equals to negative 2 in here. And based on this, I've now have the x coordinate, the first value in the xy pair for a and b. So therefore, we see that a was the value on the left-hand side, isn't that so? So it has the smaller x value. So a is then equal to minus 2, 0. And I have that b will have to be the larger of the x values. So that one will include that, which is 4, 0. Is everybody happy with the solution to this part of question 5? So are we all good? Okay, excellent. Thanks for that feedback. Right, let's look at question 2. Question 2 says, determine the coordinate of C, which was the turning point of f. And I had already discussed how we would be able to do this. So we've got f of x, and merely what we now need to do is use the formulas that I had described. Of course, I would like for each of you to understand how to derive this. This derivation was done in grade 10. I would like for you to go back and recap how one can compute or derive the formula for a turning point. Okay, but for now, because of our limitation with time, we want to calculate a lot, we want to answer a lot of questions. Let's use the formula to answer this question. So I now want the turning point of f of x, 5.2. I'm going to highlight the equation of the formula in here. Right, so f of x equals to that. That is the information that I'm now going to utilize, and I need to solve for x equals to minus b over 2a. What is b? Do you all agree that b is 4? So I've got minus 4 divided by 2 multiplied to a. What is a? A is minus 2. Do you all also agree with that? And now what do I have? I've got negative 4 being divided by negative 4, which gives me a value of positive 1. So that's the x coordinate. I now need the y coordinate, which means I need to evaluate f at 1. Isn't that so? And what is f at 1? So it's minus 2 into 1 squared plus 4 multiplied by 1 plus 16. And what do we get in here? I get that the answer is 18. Right. So is it clear that therefore that the coordinate of the turning point is given by, so the turning point is x equals to 1 and y equals to 18. Let's come to the chat box and see if there are any other questions that we have. All right. Okay. So we would like for this to be slowed down a bit. Sure. Would you like me to recap on my solution for 5.2? You can just respond to me in the chat box. Yes, okay, absolutely. Let's go back and review what the question asked. So we were given a parabola and we're given a straight line, okay? These graphs have been plotted on the XY plane, so I can see it. Right, we've got the picture in here. Here is F. The yellow graph is the parabola. And then I've also been given the picture for G of X, which is a straight line. And there it is drawn here. Okay, so I've color coded it for you. The first question said, find the coordinates of A and B. So what we needed to do was observe where A and B lived. Where did A and B live? Well, they both live on the yellow graph. Do you see that? They both are coordinates of the parabola. In particular, I observed that A and B are the x-intercepts of the parabola, meaning they are the roots of the function. And that is why, in order to solve 5.1, we solved for the x-intercepts of f of x. We had equated f of x to 0. We had factorized, and we had saw that the x coordinate for the intercepts were going to be 4 and negative 2. And that is how we solved for the coordinate of A as well as the coordinate of B. Then we went on to answer question 5.2. Question 5.2 said, determine the coordinate of the turning point. Now, at the start of this question, I had recapped on some properties of parabolas that you would have learned from grade 10. The first thing is that this is the general form of a parabola. This is what it looks like. It's of the form ax squared plus bx plus c. Okay, so that is what we learned. We also know that by looking at the first coordinate, if it was positive, I get a happy face. If it was negative, I get a sad face graph, right? So I'm looking at the shape of the graph. Then we also know that when you have a happy face graph like this, then it has a minimum value, right? Which I put here with the dot. And when you have a sad face graph, then it has a maximum value. In particular, these values, these dots that I've drawn, in our graph, it coincides with the coordinate of C. That is called the turning point of the graph, because the graph is now rising, but at C, it suddenly decides that, you know what, after I pass through C, I'm no longer going to rise, I'm now going to fall. So therefore, we call it a turning point because the graph turned at C. Now, in grade 10, you would have learned theory on how to calculate the coordinate of the turning point of a parabola. We had seen that the x coordinate, so I told you it's given by x comma y. We had seen that the x coordinate is given by minus b over 2a, and you're merely picking out the a and b value from the function. They are the coefficients of x squared and x respectively. And then once you've got the x, well, that's fine. Take it and plug it in to the function f so that you can get out the corresponding y value. And that is what we were doing in 5.2. So we took our function, which I had highlighted above. I needed to calculate minus b over 2a. The b is 4, so I plugged in minus 4. The a is -2, so I've got 2 multiplied to -2, and that means that the answer when simplified is 1. So that's the x value. In order to find the y, I need to take the 1 and I need to plug it into the function f. So that's what I did. I took 1 and I substituted it in place of x everywhere. And I saw that the answer was 18. Is that now a lot better? Is everybody now happy with the explanation for question 5.1 and 5.2? Okay, great. Carolyn, I'm glad that this is now better. Right, let's carry on. Now we've got 5.3. 5.3 says determine the range of the function. What is the range? Right, so can someone explain what the range of a function is? Right, so the range in here of a function refers to all of the values such that, okay, let me write it down like this. It is the collection of all the f of x's such that x was an element of the domain of f, right? So considering all of the values from the domain of the function, what are the y values that this parabola, the yellow graph, is allowed to attain? What do you think that range is? Okay, great. Lots of responses coming in. I'm glad. Right. So remember, I told you that in the case when a is negative, like what we have, you have the sad face. That's the shape of our yellow graph, and it attains a maximum value. So it means y attains a maximum value. What was the maximum y value? We had calculated it, isn't that so? We saw that this was equal to 1,18. So I know that the maximum y value that this yellow graph can attain is 18. And so what I can then say is that y can be less than or equal to 18. Does everybody understand that for me to answer when answering this? So this amounts to simply saying that this is all of the f of x's. Okay, maybe I'm not going to write it like that. I'll write it in set notation like this instead. I'm going to say that it's all the y's from the reals such that y is less than or equal to 18, right? So that is going to be my notation. Okay, and that is how we will write down the range of f. Now the next question says that the graph h, right? So they have defined a new graph. Let's look at this. We have a new graph. It's not depicted. This is not drawn on the question above. Okay. And we're told, well, I can create h given f. And how do I do this? Well, I take f, and the first thing that they are going to do is they will add p units to the input, and then they will add q units. It's going to be of the form where you add q to the output of f applied to x plus p. Right, we're now told that this function h that we are now creating has a maximum value, right? It has a maximum value of 15 at x equals to 2. So this here can be summarized by the coordinate 2, 15. And this is now the maximum value that h will attain. So because h has been defined from f, it will still be a sad face graph. It will still have that shape, except now the maximum value has changed. It is given by the coordinate 2, 15, whereas our original graph f was given, the maximum was given by 1, 18. So what we have to do is we have to be mindful of this, right? So this is question number, let me just remind us, 5.4. Okay. This is 5.4. The maximum of f, the turning point, was given by 1, 18. That's the max coordinate, right? So this is the maximum coordinate. And then similarly, the maximum coordinate of h, we have been given this in the question, and we were told that that is going to be, let's go back. I wrote it down as 2,15. Okay, so what we should do in order to determine the values of P and Q is we now need to investigate what changed. So what was the change in here? Firstly, I can see that clearly X had changed, isn't that so? I see that X changed from 1, and in order to get to H, it increased to 2. So this was this was a change in how many units? For 1 to move to 2, this increased by 1 unit, isn't that so? And then I observe, well, the Y values also changed. And what happened to the Y values? Originally, it was 18, and now it decreases to 15. What is the change in here? The change is -3. So that is what I now want to take heed of. I want to observe what is the change in the X values and the Y values. Now, what I need you to remember are your rules of translation. Okay? So what are the translation rules that you had learned in school? So when you add a value to Y, to the output of a function, right, we simply say, if I've got f of x, then I will just add the q to it, right? The change. If I'm minusing 3, it means I've shifted the graph down. If I'm adding 3, it means I've shifted the graph up, okay? But now here, this change is not about the output f of x. This change here is affecting the input x. And when you study translations in grade 10, you would have learned that when you make a change to the x values, it's counterintuitive. You do the opposite of what has happened. So here, when x increases by 1 unit, we then summarize this as, so I'm affecting the inside, so I have to affect the x. So when it increases by 1 unit, well, yes, I'm going to affect it by 1 unit, but instead of adding 1, I will now subtract 1. And so therefore, the p value that we look for is given by -1. Okay, so there were some answers in the chat box. So let's see. Let me go back and double check what responses we have. Okay, great. Right, so here, this is actually our f of x plus p. And here, when we were writing this bit down, this becomes our f of x. And in our case, we are minusing 3. So I say -3. So what is the p and what is the q? To answer the question, the p that I was looking for is -1. And what is the q? The q that I was looking for is -3. Right, so is everybody happy with this part of question 5.4? Does anybody have any questions, or is there any part that you would like me to re-explain? Let's take a look. What's the feedback? Okay. Okay, I'm still waiting some feedback, so let's see what we've got. Okay, so it seems that you would like for me to, okay, somebody wants to know why negative. Okay, yep, that is a good question. Why is it negative? So when you're saying negative, on which part? Are you asking about negative on the x, or are you asking about negative on the y? That's what we want to double check. Can you just let me know? Right. So I think both the x and y. Okay, no problem. Right. Let's go and look at this. Okay. So in here, we are analyzing the change from f to h. We are creating h using f. So I need to analyze the change that has occurred in there. Okay. So when I have f, I've got 1 and 18. To get to h, I now have to change the 1 to 2. Do you see that? 1 must now become 2 and 18 must now become 15. So what you need to now observe is what has happened to the x and what has happened to the y. So the 1 increased to obtain 2 and the 18 decreased to become 7. I think with that we are all clear, right? Now, let's talk about the y first, because the y is an easier concept to understand. When I want to shift a graph up or I want to shift a graph down, it's a really simple thing. I simply say f of x plus a constant to move it up where the constant is positive. Or if I want to shift f of x down, then I will say f of x minus the positive constant. So in our case, we are subtracting 3, which means our graph is moving 3 units down from what it originally was. It moved from 18 to 15. So that becomes f of x minus 3. So on the y bit, are we clear on that explanation? All right. Then when it comes to x, I had explained that it's counterintuitive. So here we have that x has increased by 1 unit to 2. But when you translate this mathematically and you're affecting the input of a function, right, you don't say plus 1. If the graph has moved to the right, that means that the x values has increased. If it has moved to the left, it means that the x values has decreased. I mean, if you're looking at your picture, right? So now when it's moving to the right, instead of adding the units, we subtract it. So it's moved to the right, right? It's moved to the right by 1. So we will subtract 1. And therefore the p is now minus 1. And as I explained earlier, the q value is minus 3 because we subtract 3 to move the graph down. So is that a little bit better now? Okay, excellent. Right, let's go to the next part of the question. We are quite slow, so let's try and see how much we can do. Next part says, determine the equation of G inverse in the form of, okay, so what is G? G is given by 2x plus 4. Right, we want to find the inverse of it. I think this is 5.5. G of x is equal to 2x plus 4. I'll double check this before we start answering the question. Yes, g of x is 2x plus 4. We need to find G inverse. Right. So before you find an inverse, one must know whether the inverse exists. And in the case of a linear function, we know that it will always exist. Okay, so that's fine. So existence is guaranteed. So once we know that it exists, I can now try to find it. How do I find it? The idea is we are going to do a swapping of the coordinate. I'm now going to replace the y, right? So this is the y by x, and I'm going to replace occurrences of x by y. So that means that I now get that x equals to 2y plus 4. And then what do I need to do? I now need to solve for y and make y the subject of the formula to now get out the description of G inverse. That is the idea. Okay, we already got some answers coming through, but let's solve this together. So I then see that 2y equals to x minus 4. Okay, we can observe that by subtracting 4 from both sides. And then I observe that y equals to a half x minus 2. And so this is in its simplified form. This is a straight line equation where we have a gradient of a half and a y-intercept of 0, comma minus 2. All right, so this is now the function that describes G inverse of x. And that is how you are expected to lay out your solution. Okay, so I think that we are now all good on question 5.1 to 5.4. I'm now ready to move on to another question. So let's talk about the following. So now I have h of x is given by -3 divided by x minus 1 plus 2. Okay. And it says, write down the equations of the asymptotes of h. So firstly, looking at this function that we've been given, what type of graph does it describe? What is it? We've just investigated parabolas. Yes, this is a hyperbola. Okay, and when you had learned about hyperboles, sorry, that's an A, not an E. Right, so when you learned about the hyperbola in school, you were told that the general form is given by k over x minus p plus q. Okay, and if you observe right now in this picture, sorry, in this question, we have a function that is described precisely in that form. Okay, we know that the value of k actually helps determine, right, exactly where the graph should lie, isn't that so? So when k is positive, then I know that the graph lies in the first, typically it would lie in the first and third quadrant, unless it was shifted up and down or left and right, right? Just depends on translations. So maybe what I can do is I can be a bit more clear that this is k over x, okay? That's the general shape. And then if the k was negative, then it lies like that in the second and the fourth quadrant. So here our k is negative, so I already know that my picture is going to lie in the second and the fourth quadrant. Now it says we want the asymptotes, right? So let's look. We've got lots of responses and we've got the answers for the asymptotes. As someone says, it's going to be x equals to 1 and y equals to 2. Let's investigate. Right, so we actually read out the asymptote from there. And yes, we then observe that clearly the vertical asymptote, right, the vertical asymptote, so this is question 4.1.1, is given by, well, I would just have to solve x minus p equals to 0. That's what I would have to do. But what is our minus p? So we've got x minus 1 equals to 0, and that tells me x equals to 1. So that's my vertical asymptote. Our horizontal asymptote is given by y equals to q. And we then see that this is y equals to positive 2. So this is the asymptotes that we were requested to find. Okay, right, next part of the question. What are we required to do next? Right, so now what we want to do is I want to determine the equation of the axis of symmetry that has a negative gradient. Okay, so let's get a better idea of what they actually mean, axis of symmetry with a negative gradient. Let's draw something. Right, so that's my x, and this is my y. And then right, now I need to draw x equals to 1. So let's firstly suppose that this is, okay, so let me let that equal to 1, and then I need y equals to 2. Oh, sorry, let me share again. Not sure what's happened. Okay, I'm just going to reopen that bit that we were working on. Right, here's the question. It's back up again. Unfortunately, what's happened is the program has shut down and what I was writing was not saved. But nonetheless, we remember the answers that we had written down, isn't that so? We saw that the one asymptote was x equals to 1 and y equals to 2. So that's what we were drawing. And now let's draw that. Okay. And I labeled the value in here. I said that's 1, and I said that will be 2. And now I need to essentially sketch these straight lines that represent the asymptotes. Right, so the blue dotted lines represent the asymptotes that we were expected to draw. This is x equals to 1, and this is y equals to 2. Now, based on the fact that this is negative at the top, the k at the top is negative, we know that our picture is basically going to lie here, and it's going to lie here. And we also know that this is a mirror image of this. So the curve that I've drawn here is a mirror image of this, and it would be a line. Oh, what have I done? Let's see. Oh, have I done the wrong thing? We need a negative gradient. Let's quickly take a look. Okay, yes, I've been doing the correct thing. Right, I'm not sure why. Okay, let me go back to this. Let me draw those pictures in again. Right, so I want the equation of the axis of symmetry of H that has a negative gradient. So the axis of symmetry needs to pass through this point. It needs to pass through the point x given by 1 and y given by 2. Do you agree with that? It must pass through that point. So now that I know that it must pass through that point, they've also told me that it needs to have a negative gradient. So that means that my gradient should be -1, because our axis of symmetry, usually when it passes through there, it should have, for example, if your y equals to x, right, being reflected along that line, we hold a positive gradient of magnitude 1. So we want an axis of symmetry with magnitude 1, but now it needs to be negative. So hence -1. Now, for us to do the calculation, I now have a gradient as well as I have a point, right? So I've got 1, 2. So using the point, right, we can use the gradient intercept formula that we usually learn. And I'm now going to substitute in the value y equals to 2, the gradient of -1, x equals to 1, and we're going to solve for the unknown of c. So if I do that, I get that 2 equals to -1 plus c. And therefore, we observe that c equals 2. So I would essentially add 1 to both sides. It gives me a value of 3. So therefore, the equation of the line going through the axis of symmetry with a negative gradient is given by y equals to -1x, right? So I'm just going to say -x plus 3. Is that the solution that you had given me? Okay, great. I see many of you had given that answer. Right, next bit. Sketch the graph of H showing the asymptotes, the intercepts, and the axes. So I've technically already given you a picture, isn't that so? What's missing in here? I have not told you what the intercepts are. So we know that we should expect a y-intercept, and we know that we should expect an x-intercept. So let's now go ahead and let's solve, right? So how do I find an x-intercept? To find an x-intercept, I'm going to let y equal to 0. Okay, what is the equation? Let's remind ourselves. It's -3 divided by x minus 1 plus 2. Okay, so I've got 0 equals to -3 divided by x minus 1 plus 2. So this then tells me that 3 over x minus 1 equals to +2. Okay, I think we're all good there. Then what I'm going to end up doing is I will multiply both sides by x minus 1. So I've got 3 equals to 2 into x minus 1. This then tells me that 3 equals to what am I doing? I'm solving for x, right? This equals to 2x minus 2, okay? And then I'm going to add 2 to both sides, so then I get 5 equals to 2x. And then I can solve for x, and I see that x equals to 5 over 2. So this then tells me that therefore the x-intercept is given by the coordinate 5 over 2, 0. And I can now plot that value on here, isn't that so? This is precisely 2.5. Let's now calculate that value on the y-axis. So for that, I now need the y-intercept. And that means I'm going to let x equals to 0. So y equals to, what is the question? There we go, minus 3 over x minus 1 plus 2. So I now replace x by 0. Okay, so let's replace it by 0. So that's minus 3 divided by minus 1, which gives me a value of positive 3 plus 2, which equals to 5. And so I then see, well, this coordinate here is actually 5. And the y-intercept is given by 0, 5. So that's it. That's how we're expected to solve this question. How are we doing with this one? Is everybody all good? And can we now move on? Right, so that is precisely what you needed to do to answer this question. Okay. Right, there is another question on here that I also wanted to cover, because our first question that we did was in a parabola. The second one looked at hyperbola. And now this one is dealing with exponential functions, okay? So it says that we have f of x equals to 3 raised to the power minus x. A is the y-intercept of f, right? So this is what we're given. Right? B is the point of intersection of f with the line y equals to 9. So immediately what this means is that the y coordinate of B, the y value, is equal to 9. So this is of the form x comma 9. So it is the x that is unknown. So the first question says, write down the coordinates of A. Is that something that we're able to do? This is the y-intercept. Okay, and we know what the function is. So A is the y-intercept. So that means all I'm doing is I'm replacing x by 0. And so I see that y equals to 3 raised to the power, it's negative x, but I replace x by 0. And 3 raised to the power 0 is precisely 1. But in any case, that is a fixed property when it comes to exponential functions. We learn that if you're just working with a base raised to a power x or negative power, then the y-intercept is given by the coordinate 0, 1. Okay, so yes, so therefore the coordinate of A, so the y-intercept, is 0, 1. And so I can even write that on there immediately. Right, so I think we're all happy with that. The second question is determine the coordinates of B. So this is 5.2. What did I already say earlier? Well, I did observe that clearly the y coordinate of B has to be 9, right? Because it's given on the graph. So I've got f of x equals to 3 to the minus x equals to 9. So this is what I now want to solve. I want to solve 3 raised to the minus x equals to 9. I want to solve for x. That's the idea. That's going to help me get out the coordinate of B. Right, so in order for this to work, we should have like bases, but I can express 9 as 3 squared, isn't that so? And when you have the like bases or common bases, then we can simply work with the exponent. So this tells me that negative x equals to 2. So therefore, that implies that x equals to minus 2. And so now I know immediately that this coordinate, this x, I can now replace it by minus 2. So it's minus 2, 9, and that is the coordinate of B. So that's the answer. So to answer the question, B equals to minus 2,9. That's it. Right, next bit. Write down the domain of f inverse. So remember, this function is f. Now, what property do we know? What relation do we know about functions and their inverses? Right? So if I want to determine the domain of f inverse, what I actually have to do is investigate what is happening with the range of f. Okay, so 5.3, the domain of f inverse, and I can say this because this function is it's single rooted, meaning that this function is one-to-one. So therefore I could state these things. Okay, so the domain of f inverse is the range of f. So this is what we now want to investigate. So what are the values that the range takes on for f? Here's the picture of f. It is precisely the graph that is drawn here. Tell me, what values are permitted for the range? Okay, great. So I'm seeing precisely the same explanation. Thanks, Keuru. Right, so we see that the values here in the range is all values that are bigger than 0, isn't that so, for the y? So the y must be bigger than 0. So if I translate that now to talk about the domain of f inverse, it means that I'm going to only consider all of the positive values. So therefore, oops, that's a highlighter. Therefore, the domain of f inverse is going to equal to all of the x's in the reals, right? Because we're going to work on the x coordinate, but we're only going to take the values that were positive. So it will be all x that was strictly greater than 0. Because remember, the range here, this exponential graph does not equal to 0 at all. It approaches y equal to 0, but it will never attain a value of y equals to 0. Y equals to 0 is an asymptote, isn't that so? And therefore, all of the values in the range of f, so the range of f was all y bigger than 0. This was an asymptote. And so since it was only considering positive values, it means that the domain of f inverse will therefore only work with the positive values, and hence it will take all x greater than 0. Are we all clear on this one? All right, let's look at the next bit of the question. Describe the translation of f to h of x. So again, I know what f is. Let's remind ourselves of that equation. F is given by, f of x is given by 3 to the minus x. Now we're given a new equation, h of h, and we're told it's 27 divided by 3 raised to the power x. Okay. So now what I need to do is I need to take this function h of x, and I now need to have it rewritten to have some type of form that resembles f. That's what I would like to do. So I take the h and I will rewrite it. So how could this be rewritten? Well, firstly, I observed that this is the same as 27 times 3 to the minus x. I think you would all agree that I'm allowed to do that by rules of exponentiation. And then I observe, well, you know what? 27 is nothing but 3 cubed, isn't that so? So I've got 3 cubed times 3 raised to the power minus x. And then, well, I've got like bases. So if I'm multiplying, I can add the exponent. So if I'm going to do that, then this is 3 raised to the power 3 minus x. Okay. But then I could rewrite it as 3 raised to the power, and I pull out a negative, and therefore I have that it is x minus 3. There we go. And this is it. So that is now how I have expressed it. So can you see that this now slightly resembles the form of f of x? So this is now nothing but, this is now f of x minus 3. Do you agree? Look at that. Isn't that the case? You simply replace the x by x minus 3. And you would then get out h of x. So essentially, h of x is equal to f of x minus 3. And using this, we can now translate exactly what happens. So this tells me that h of x is obtained by shifting the graph of f 3 units to the right. Remember, I told you when you affect the input, you do the opposite of what is being described. It's counterintuitive. So instead of going, so because there's a negative, I will go to the right. So I will move f of x 3 units to the right. That, would anybody like me to explain anything? Okay, so I'm just going to recap on what was done in 5.4. It says give the translation that describe the translation from F to H. So we're given H, and what I did was I analyzed how H was related to F. I had manipulated the description of the function H of X, which is 27 divided by 3 raised to the power X. And I saw that it can be written as 3 raised to the power minus into x minus 3. And that's nothing but the same equation here, f, where you replace x by x minus 3. And now you have to use all of your rules about translations, reflections that you would have learned in grade 10. We learned that when you affect the input and when you subtract 3, you move the function 3 units to the right. If we affected the input and we added 3, I would have moved 3 units to the left. So that is the theory that I was now utilizing to explain in here. Okay, so we've got that this function h is nothing but f of x minus 3, which means that in order to obtain h, I take f and I shift the entire function of f 3 units to the right. Okay, now we have a few minutes left, and I had also planned to discuss trigonometry with you. So let's talk, maybe let's answer one question together in the time that we have. Now, what are some of the things that you would have learned in the first term pertaining to trigonometry? Well, you would have learned compound formulae, isn't that so? Okay, so you would have learned compound formulae. Okay, so these were compound formulae. Right, and essentially what it does is it gives you a formula for the expansion of the sum of angles inside sine, and similarly the difference, or the sum of two angles evaluated by cos, or the difference of two angles evaluated by cos, etc. Right. So essentially, I mean, if I had given you, so of course there were proofs that were done to show you why this is the case, but in a sense, if I give you sine of alpha plus beta, you could use that formula to derive sine of alpha minus beta. So in a sense, what I'm trying to tell you is that you don't have to memorize formulae. But in any case, it's actually true because what I've listed here appears in your formula sheet. So don't memorize, but at the very least understand why statements can be expressed in the following way. Right, similarly, you could derive cos 2 alpha by calculating what is cos of alpha plus alpha. Right, so all of these things could stem from one given formula, and I hope that you were able to observe patterns in these formulae. Right, so these were compound formulae, and then the second set of formulae in here, these pertains to ones that have geometric applications immediately with questions. So the first one was your sine rule, which you would have learned this year, or perhaps you learned it in grade 11. I think you did. Then you've got your cosine rule. And lastly, you've got the area rule. Okay, so typically in the exam, you get assessed on various things. You would be getting assessed on trig with diagrams. You would be getting assessed on reduction of formulae. What else? Negative angles. And all of these trig concepts would have been introduced to you from grade 10. So the idea is for you to go back and relearn your grade 10 concepts, relearn the grade 11 concepts, as well as what you would have learned this year. In grade 12, you're going to be assessed on all of them. So you have to know everything. Right? So of course, you learned negative angles. You would have learned how to solve trig equations. Right? Solving trig equations. And then, of course, you would be assessed on these new concepts. You would be given diagrams, real life situations, and you would be required to solve for specific values using sine, cosine, and area. Okay, let's look at the following one. I'm going to start you off with this question, but we have limited time. Let's look at what we've got to do. It says in the diagram, we are given a point. Right, so I'm given the point -5, 12, that is P. Okay, it says T lies on the positive axis, so that's there, and the angle POT, so the angle here is theta, so that's important, so we're given that. The question then says, and when it comes to a question of this type, this is always asked, so you should expect to receive this in the exam now, in the mid-year exam, as well as your trials and your finals. Something of this type always appears. Right, it says, answer the following without the use of the calculator. It says, calculate the value of tan theta. The first thing that you should do when you are given an angle, regardless of which quadrant it appears in. So of course, this angle subtends to some line here in the second quadrant. That's what we can see. But immediately what you could then do is you can now form a triangle with a right angle in it that allows us to now say a few things about this triangle that of course is created using angle theta. And what we have is the X here, the base is 5 units and the Y value is 12. So that's the first thing. It's the hypotenuse that is unknown to me, so I'm going to label that R. We're going to observe that perhaps we're going to need to calculate it. Now, I need to know what is tan theta. So remember, you've got SOH COT. Okay, so TOA is telling me that it's opposite over adjacent, which means it's Y over the X value, isn't that so? So what is the X value in here? The X value, well, is technically 5 units. So I'm going to write down 5 units. Sorry, I need the Y at the top, isn't that so? So it's 12 because I need the Y. And the X value is 5 units. But technically this was on the negative side. So maybe this might be a good way for you to remember to put your negative in, because this was on the negative x-axis. But another way for you to think about why a negative belongs in here is to think about the angle. Right, you would have learned about your cast diagram. Isn't that so? And what the cast diagram tells you, it tells you in which quadrant all of the trig ratios would be positive. So right now I am computing tan of theta in the second quadrant. Should tan of theta be positive in there? Well, clearly it shouldn't, because only sine is positive, and that is why there should be a negative sign in there. So one way to remember this is, well, it's negative because the 5 had a negative coefficient. It was on the negative side of the x-axis. Or the other way to remember that a negative belongs here is to think about the cast diagram. And you're computing tan, you're computing it in the second quadrant. Therefore, it ought to be negative. Right, so that's the answer there. Next bit, calculate cos of theta. I need adjacent, which is x over r, the hypotenuse. How do I compute r? Well, r is going to be the square root of x squared plus y squared. And this is merely equal to, what is my x? It is 5 squared plus 12 squared, 25 plus 144. Root that, you should get a value of 13. Just double check, is that 13? Okay. So now that I have that, cos of theta is adjacent, which is the x value. So once again, it's 5 units over 13. But remember, this was -5. So I'm going to put the negative down because we had a -5. But more importantly, you can see that cos of theta should be negative because cos is not positive in the second quadrant, only sine is. And that is why we've got negative values in there. All right, let's answer the last question here. It says that S is a point in the third quadrant. Okay, fine. S is a point in the third quadrant. Let me make space to draw something in here. Such that TOS is equal to theta plus 90. So now I need to form 90 degrees in here. So theta plus 90. So here's theta. And then if I carry on going, it's 90 degrees, which I shaded in there. Okay, so the angle between T, the origin, and S, which is now my point in here, is given by theta plus 90. So I think you all agree that this diagram is correct. We're then told that O, there's here, OS has 6.5 units. That's the length of it. It says calculate B, where B is the Y value of S. So that is it. And of course, it should be B in here. So I want to calculate B, the Y coordinate of S. Okay, how do I do this? Observe that I've got the length 6.5 and I've also got R, which is 13. So what I should essentially do if I want to know what B is I should write down a trig formula that has B, the length of B in it, isn't that so? Wouldn't you agree? So how do I go about doing this? Any suggestions? Why don't I say the following? Why don't I say sine of 90 plus theta? What is sine? Sine is, I didn't write it down, opposite over hypotenuse. So actually, the triangle that I'm now looking at is the following triangle. In here. Okay, and that is also fine. And so I see that it is going to be B, it's Y over H, Y over the hypotenuse. So here is my hypotenuse, here is B, and of course that's the adjacent, right? So the purple triangle is the right angle triangle that I'm now working with. And the angle that we consider is theta plus 90 degrees, right? So it's the upside down one. So sine we saw is opposite over hypotenuse. The opposite value that I want is B over the hypotenuse, which is 6.5 that was given. And now this is something that I can now solve because this is equal to cos theta equals to B over 6.5. But do I know what cos theta is? Actually, yes, I do. I just calculated it in 6.1.2. It is -5 over 13 equals to B over 6.5. And therefore, we can now solve for B, isn't that so? So by solving, I then see that B is equals to -5 times 6.5 divided by 13. And I am now going to leave that to you to write down the final answer. And this is where we will conclude today's lesson. I do hope that you found it helpful, and I wish you all the best for your upcoming first-term examinations. Please stay tuned and check out social media for the new dates for the upcoming lessons. But more importantly, I want to remind you about the following program that we're hosting tomorrow. It's going to be a phenomenal program. I hope that you've all registered. If you haven't, you can drop me an email and I can send you the details. So I hope to see you all there at 9 o'clock tomorrow. There's going to be amazing talks by mathematicians, as well as a fun quiz that you can participate in to win prizes. Right? There will be cash prizes available. So don't miss out on the opportunity to come in and have fun and learn about mathematics. So I hope to see you there. And thank you all for joining me today. Right, I'll see you next time.